Hello, I'm Olga Lucía Castiblanco Abril. I'm a professor at the District University Francisco José de Caldas in Bogotá, Colombia. My colleague Luis Sebastian Gonzalez was my student in a physics teacher program degree. This is the Sebastian's degree work. We entitled Training Teachers for New Ways of Understanding the Teaching of Physics from its Mathematization. There are a big problem and about the understanding in the relationship of physics and mathematics. Some of the questions that are at the base of this research line are, is physics just math? Is math just equations? Is the physics teaching better without mathematics? From the common sense of the teaching, the answer could be yes. But from the research in physics teaching, the answer is no. Our objective is to propose an alternative to the comprehension of the physics mathematization process in educational settings, in a differentiated way to the physics mathematization throughout the history, because we believe that epistemologically it's really different to produce physics along to the history than produce physics in an educational process. Our research methodology is a participant observation. I was the professor who teach in a didactics of physics course, and my colleague Sebastian was the researcher who take notes from class and produce audiovisual records. After take data, we applied content analysis techniques to produce results. Our theoretical framework, of course, we have a lot of authors from the Ibero-American context and as well from the Anglo-Saxon context, who research the relationship between physics and mathematics in the classroom. But we can tell you about our history in this research line in our research group. We have a learning and teaching physics research group, and we have a history in this topic. In 2003, I made my master thesis entitled The Mathematical Beauty of Paul Dirac as an organizational criterion to model the laws of physics in the emergence of quantum physics. My purpose at that time was to study how that physicists like Paul Dirac imagine the relationship between physics and mathematics, and was really amazing to find that it's really different that the teachers used to think about it. And after that, Vizcaíno, in 2013, took these results and studied the concept of physics mathematization in educational processes from research results on physics teaching and from the students and teachers' perceptions. He found at least 3 tendencies to think this relationship. One of them is based on modeling. Imagine the equations as an explanatory model. Another one is based on the phenomenological studies, more qualitative than quantitative studies. And another one is based on the physics mathematics processes. But all of these tendencies we found a little disarticulated. After that, in 2016 and 2017, we make 2 studies with Ruiz and Perez. They studied the conceptions about physics and mathematics in the talk of preservist teachers. And we studied also with Sierra the epistemology of physics in teaching. And this work is the last one in this sequence. Well, as a professor, I planned and taught a course, a didactics of physics course, focused on teach to my students how to prepare the physics class in a different paradigm between this relationship. And we taught them about 3 phases, 3 articulated phases. The first one is the phenomenological approach. It is about to educate the thing of the top of the student to see the phenomenon, because they have to understand what is the phenomenon with the reason, with the mind, with the eyes. And when they can see and when they can talk about a phenomenon, they are ready to study the physics system. In an observation process, we analyze the difference between the observer, the observed, and the observable, and we teach how to characterize systems, identifying variables, parameters, constants, and relationships between all of them. And the last phase in this process is modeling. It is about teach how to synthesize of the observation, all the observations, and organize an explanatory model from each student, not memorize the explanatory model of the science, but create our own explanatory model. And we teach them also about criteria to choose activities that came to stimulate these phases from typologies of technologies or experimentation or literature. Well, when we finished this part of the course, was at least the middle of the course, we asked for the students, future teachers, pre-service teachers, to create their own process to teach one physics concept. They have to choose the concept and they have to teach this concept to their colleagues, to their classmates. And well, I will present some of the results. One of this group decided to teach the concept of quantum entanglement, exactly because they consider that they didn't understand so well and they want to go further or in deep of this concept. They create these 3 steps. From the phenomenological approach, they they made historical analysis of the conditions for the emergence of this concept. Discussions on why 2 photons could be connected, even though they are far apart. Nobody had the truth. Then students just wanted to be together and made honest dialogues. And the second step, about the observation of the systems, they imagine a mental experiment to exemplify what the phenomenon consists of, against which many questions were generated about the logic that would explain that. If one particle is altered, the other reacts instantly. The debate was about how they were able to create so different rules from what is known in classical physics. And at the final, the discussion was about all the new paradigms of correlations as non-local and quantum causality as something that is made to exist and not something that is the effect of unknown cause. Reflections on the meaning of Bell's theorem about the non-existence of local hidden variables in the quantum world was made. Okay, the second group decided to teach space-time concept, and they create these 3 phases. The first one is a text analysis from original papers about the discussions between Newton and Leibniz, focusing on the reasons to believe in concepts as absolute time and isotropic and homogeneous space. This is the base to go to the relative concept. About the observation, they designed resources with an elastic material, latex, where they drew different figures that deform when stretching the latex in different ways. They make an analogy with the behavior of deformed space and the causes that would deform it, which creates relative distances between 2 points and therefore different times to go from one point to another. Also, they created physical models to exemplify the Minkowski diagrams, which would explain the geometry of space-time. And at the final, they programmed a simulator, they create a simulator to exemplify the phenomenon of the twin paradox using Minkowski geometry. It was based on the book, The Philosophy of Physics by Tim Maudlin. The third group decided to teach the entropy concept. They began debating from a video showing the reaction of the mixture between citric acid and sodium bicarbonate, analyzing the necessary conditions for effervescence to occur. Then they developed several illustrative experiments where they could make variations to the materials used, generating different chemical reactions where a kind of irreversible disorder or order could be characterized. While the second phase, they try to observe how the macro and the micro states of a system, what is the behavior? And they introduce this concept and the relationship between them and what it means in the Carnot cycle. They started. Okay, at the final, a probabilistic type experiment was created to talk about the probability distribution and the concept of permutation and counting. Well, many debates and many aspects were studied and analyzed, but we can conclude the pre-service teachers recognize the value of debating with arguments created by them, not just repeating what the books say. They express their doubts without fear of being judged, since they all place themselves in equal epistemological conditions. They recognize that modern physics can have strictly defined boundaries between the observer and the observed and the observable. They evaluate discourses from history, epistemology, and philosophy to broaden their understanding of the phenomenon, and also develop criteria to identify the fundamental concepts of phenomenology and study, understanding the importance of learning to identify variables, parameters, and constants in a physical system. But overall, they created their own teaching strategies by adopting a new way of linking mathematical thinking with the study of nature. And they believe that they understood so much. Okay, there are some of our references, and thank you so much for listening to us.